So this topic is about group 2 and group 7 of the periodic table, and most part of this topic you will find in unit 3, which is about the practical course. So most of the things related to some tests and observations you have to learn from this chapter, which you will use for answering unit 3. So starting with the first part, which is about group 2 and 7. The group 2 elements, we have beryllium is there, magnesium is there, calcium, strontium. These are the group 2 elements. What about the atomic radii? When we compare what happened to the size of an atom as we go down the group. So atomic radii increases. What is the reason why the atomic radii increases? And this happened for all the groups, because when you go down the group, the number of the shell increases. Like if the first one we have example 2 shells are used, the second one 3 shells will be used. That's why for all the groups, whenever we go down the group, the size or atomic radius will increase because they have greater number of electron shells. The second point is the melting point. So going down the group, these are the periodic trends. You have to learn these periodic trends as well with a reason. So as we go down the group, what we observe the melting point is decreasing. So what is the reason why down the group the melting point is decreasing? As in metals, because group 1, group 2, these are metals. And what is the structure of the metal? They have a lattice of a positive ion and the delocalized electrons. So there will be a lattice of the positive ions, and we will have the delocalized electrons. Electrons will be there which are free to move. So these electron drift or these electron move from one place to another. So as we go down the group, because the ionic radii or the radius increases, so the attraction between the electron and the nucleus that decrease, because the positive ion is attracting the electrons, and that electrostatic attraction between the positive ion and the electron is known as a metallic bond. So that is the electrostatic attraction between the positive ion and the free electrons. So what happened in case of the metals? The positive ions, as we go down the group, the size of the positive ion is increasing. So as the size is increasing, and they have a charge of +2 because we are talking about group 2 elements. So as the size is increasing, the attraction between the electron and the positive ion that weaken, and due as this attraction, a weak attraction is there, as a result what happened, that the melting point will also decrease. So this will have a strong attraction because ion, the net charge on this ion is +2, and it is attracting the electron, and it is the electrons are closer to the positive ion, or we can also say nucleus of this positive ion. But in this case, the second one, as the size increases, the distance between the nucleus and the electron, the delocalized electron, that also increases, so attraction decrease, which leads to lower melting point. So down the group, the melting point of group 2 will decrease. Is it clear, this part? That why as we go down the group, the melting point is decreasing. And this is valid for group 1 as well, because group 1 are also metals. The ionic radii increases, so attraction between the positive ion and the delocalized electron, that decrease. That's why the melting point will also decreases. The third is the trend in ionization energy. What is the meaning of ionization energy? Ionization energy means energy needed to remove electron from a neutral gaseous atom. We call that as an ionization. So for group 2 elements, if we have beryllium is there, magnesium is there, and then calcium. So all have 2 electrons in the outermost shell, So this question, if they ask like why as we go down the group, the ionization energy decreases. What is the reason why? It is easy to remove electron from calcium as compared to that of magnesium, and magnesium it is easy compared to that of beryllium. So what is the reason? The first shell it will have 2 electrons, second shell 8. This will have first shell 2, second shell 8 electrons will be there. And for calcium it will have first shell 2, second shell 8, third shell as well 8 as well, and the last shell it will have 2 electrons. Now what happened? Two reasons are there. Number one is the distance between the nucleus and the valence electron or last shell electron. So distance is more, distance between the nucleus and the valence shell electron increases. So as the distance increases, there will be weak attraction. That's why it will be much more easy to remove electron from calcium as compared to that of beryllium. Then there is also a second thing, which is about the shielding effect. Shielding effect is means like how many inner shell electrons are there, how many electrons shield the nucleus, surround the nucleus, so that the valence electrons won't experience the same attraction. So when we check the shielding effect for beryllium, only 2 electrons are causing a shielding effect. For magnesium, 10 electrons are causing a shielding effect. But in case of calcium, 2, 8, 8. So it is 18 electrons are causing a shielding effect. So in case of calcium, there's a greater shielding effect. So as we go down the group, there will be a greater shielding effect, which reduce the force on the valence electrons. That's why ionization energy, this will always be a periodic trend that for ionization energy, as we go down the group, it will decrease. Is it clear the reason why as we go down the group, the ionization energy is decreasing? Any doubt till this point? Look, two things are there. One is the distance between the nucleus. This is a nucleus and this is a valence shell electron. So as we go down the group, the distance between the nucleus and the valence shell electron is increasing. So as the distance between the nucleus and the valence shell electron is increasing, so it will be much more easy to remove electron from elements which are at the bottom of the group as compared to elements which are at the top of the group. So it will be easy to remove electron from calcium as compared to that of beryllium. So one reason is the distance between the nucleus and the valence shell. As it increases, so attraction between the nucleus and electron decrease, and we need a small amount of energy to remove this electron. Second thing is a shielding effect. Like as you can see, electron light charges repel each other. When we are taking beryllium example, there were only 2 electrons. So these 2 electrons are repelling this electron, and due to this repulsion, this electron won't experience the same force from the nucleus, and we can remove it. But when we check the same effect for calcium, calcium is having total 18 electrons inside. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11, and so on. So total 18 electrons are there in between the nucleus and the valence shell. And these 18 electrons will repel this electron much more as compared to 2 electrons. That's why it will be much more easy to remove this electron out. So one is the shielding effect, another one is the distance between the nucleus and the valence shell. Is it clear, this part? Then reactions of group 2. Number 1, reaction with oxygen. So group 2, as we go down the group, the reactivity increases. Why as we go down the group, the reactivity increases? Because the tendency of the metal is to lose electron a metal tend to lose electron when they react. So when we check for in case of beryllium, it will have two electrons in the outermost shell. Two shells are there and two electrons. Magnesium, there are three shells but two electrons in the outermost. When we check calcium, so again two electrons in the outermost shell, but the distance between the nucleus and the electron is more as compared to that of magnesium or beryllium. So this example, calcium is there, this is magnesium, and here is beryllium. So as the metal tend to lose electrons because these electrons are far away from the calcium, so this calcium can lose this electron easily during a chemical reaction as compared to magnesium, and magnesium can lose electron easily compared to beryllium. So that's why as we go down the group, what we'll observe the reactivity increases. Like they become more reactive as we go down the group. Then the reaction with oxygen, what will be the product when they react with oxygen? So whenever we burn or whenever we react this metal with oxygen, as a result, what it will form? It will form a metal oxide, and metal oxide, it will be a white solid. So even if it's a magnesium oxide, beryllium oxide, calcium oxide, group 1, 2, 3, their compounds are white solid. So group 2 metals will burn in oxygen, and magnesium burn with a bright flame, bright white flame. And magnesium oxide is white solid, which is having a high melting point due to ionic bond. When a metal and a non-metal react with each other, as a result, they will form an ionic bond. So magnesium plus oxygen gives magnesium oxide, and same thing will be there. Calcium plus oxygen will also give calcium oxide. And when we react this metal, like example, if we have a piece of magnesium, so magnesium develop an oxide layer on the surface. Like if this is a piece of magnesium ribbon is there, but this magnesium ribbon at the surface, what happened as a magnesium is reacting with surrounding oxygen, so the surface will turn into magnesium oxide. That's why what we have to do, magnesium oxide is not reactive, the metal oxide, as compared to magnesium. So what we have to do, we have to remove this surface. So how it can be done? We can use a sandpaper or we can use a scrubber to remove this magnesium oxide layer on the surface of magnesium. So when magnesium react with oxygen, give magnesium oxide, and the surface turn into magnesium oxide, which must be removed for further reaction. So if testing for reaction rate, like example, if you are finding the speed of reaction between magnesium and acid, so unclean magnesium would give a false result. Why it will give a false result? Example, if you add a hydrochloric acid, magnesium oxide, the top layer is magnesium oxide. So magnesium oxide plus hydrochloric acid give magnesium chloride plus water. And if we were measuring a rate or the speed of the reaction, normally when a gas is given off, what we do, we collect the volume of the gas which is given off by the reaction mixture. So when we collect this gas which is given off in this reaction, it won't be correct result. Why it won't be correct? Because the magnesium oxide does not, the top layer of a magnesium is turned into magnesium oxide, and magnesium oxide does not release a gas, magnesium release a gas, the hydrogen. Because metal react with acid, it will result in a formation of a gas. That's why whenever experiment is involved in which you are finding a rate or the speed of the reaction by reaction or a reaction between magnesium and acid is there, so if you want to measure the rate by measuring the volume of a gas, you should always use a clean magnesium ribbon, so it will not lead to a false result. Then magnesium react with chlorine. If group 2 metals, when they react with chlorine, it will form a chloride. If beryllium is there, react with chlorine, beryllium chloride, magnesium plus chlorine, magnesium chloride, and calcium plus chlorine result in a formation of calcium chloride. Then reaction with water. So magnesium burn in a steam to produce magnesium oxide and hydrogen. And magnesium would burn with a bright flame. So magnesium plus water give magnesium oxide plus hydrogen. But for others, they can react with cold water. And so when you have beryllium, beryllium is not reacting because it is relatively less reactive. You have magnesium, then calcium, then strontium, and barium is there. So as we go down, we know the reactivity increases. They become more reactive. So beryllium, when we add to water or steam, it does not react. Magnesium does not react with cold water, but magnesium plus steam, this will produce magnesium oxide plus hydrogen. And the other, like calcium, strontium, and barium, they can react with cold water or they can react with water at room temperature. And the increasing vigorous as we go down the group, as we know, the reactivity increases. And magnesium also react with warm water, and if it is reacting with warm water, it is producing magnesium hydroxide, and this is a much slower reaction than reaction of steam, so there is no flame here. Beryllium, again, beryllium does not react with even normal water or warm water or even steam. So as we go down, the reactivity is increasing. Magnesium, it is important that you, in the question, they will mention like state a product. Then you have to check whether a magnesium is reacting with the steam or it is reacting with a warm water. With a cold water or water at room temperature, there is no reaction. But with a warm water, it will form a hydroxide and hydrogen. With a steam, it will produce magnesium oxide. And then when these hydroxides are formed, because as you can see, hydroxide or alkaline solutions are there. So what we will observe, as a product, the hydrogen gas is given off. So whenever the gas is given off, what we'll see fizz, bubbles, effervescence, we can say. When we add this solid, the calcium, strontium or barium, so we observe the metal dissolve, and it dissolve much faster as we go down the group. The solution, because it's an exothermic reaction, when metal react with acid or metal react with water, these are examples of exothermic reaction. That's why the temperature will goes up as we react. And calcium, a white precipitate appear, which is, so the solubility or less precipitate form down the group. That is about the solubility trend that we will discuss later in this topic, that what happened to solubility of hydroxide, nitrates and sulfates as we go down in the group. But for hydroxide, what happened? They become more soluble or solubility increases. Then reaction of oxides of group 2. First was a reaction of metal with oxygen, and now their oxides, how they react. So first one with water, metal oxides are there, group 1, 2. These are metal oxides, or we can also say basic oxides. So when we react, like example, magnesium oxide mixed with water, it will form magnesium hydroxide. Calcium oxide mixed with water, it will form calcium hydroxide. So when they are forming a hydroxide or alkaline solution, the solution, due to the presence of OH ion, it will turn into alkali. And as we go down the group, as the solubility is increasing, as a result, when the solubility increases, the pH is also increasing. Like why magnesium hydroxide, the pH is 9, whereas calcium is pH 12. Because as we go down the group, the solubility increases. They become more soluble. As a result, when they become more soluble, there will be more hydroxide ions, like more alkyl OH ions will be there in the solution of calcium hydroxide as compared to magnesium hydroxide. Then reaction of oxides of group 2 with acid. Metal oxide, when react with acid, it will give salt and water. So magnesium oxide plus hydrochloric acid gives magnesium chloride plus water. Strontium gives strontium chloride plus water. And calcium gives calcium oxide. Calcium plus sulfuric acid, calcium oxide plus sulfuric acid gives calcium sulfate and water. Then Reactions of hydroxide, like first you have to learn the reaction of metal, then their metal oxide with water and with acid, and the third one is hydroxide. So hydroxide or alkali, when they react with acid, as a result a neutralization reaction which forms salt and water. Now, solubility of hydroxide, what we observe, their solubility, we observe they become more soluble as we go down the group. So example, we have magnesium hydroxide, calcium hydroxide, strontium hydroxide, barium hydroxide. So as we go down the group, the solubility is increasing, like more molecules can dissolve, a greater number of the molecules can dissolve. The solubility of the substance depends on two factors. It depends on the hydration energy and the lattice energy. The solubility increases, and the solubility of a substance or hydroxides. Then the thermal decomposition. The term thermal decomposition means energy needed to break the substance, or thermal decomposition is defined as how much energy is needed to break down the reactant into more product. And thermal decomposition, as we go down the group, they become more stable. The thermal decomposition down the group, they are more stable. It means you need more energy or greater amount of energy to break these substances. What is the reason for that? Like example, for any substance like thermal decomposition of carbonate, nitrate, sulfate, as we go down, it increases. What is the reason for that? Like example, if you are talking about carbonates. So magnesium ion is smaller in size and calcium ion is larger in size. And this is example, the blue circle is representing a carbonate ion. Now what happened? There is a thing, if you remember in unit 1, we discussed the polarization or distortion. What is the concept of polarization or distortion? Means it is the ability of the positive ion to attract the negative ion, the electrons of the negative ion towards self. We call that as a polarization. Because magnesium is smaller in size, so it causes more distortion to carbonate ion as compared to calcium. And what is the effect of this distortion? If it is having a greater distortion or more polarization, what this polarization will cause? It will weaken the bond or weaken the ion, the negative ion. And as a result, when we supply heat energy, when we are heating this magnesium carbonate, so this magnesium carbonate easily decompose into magnesium oxide plus carbon dioxide, because basically what happened, the carbonate ion distort due to the presence of small positive ion, and the distortion reduce the stability of this carbonate ion. As a result, a small amount of heat energy can break down this carbonate ion into oxygen and carbon dioxide, and this oxygen mixed with magnesium to form magnesium oxide and carbon dioxide. Whereas calcium carbonate, because calcium is larger in size, so it means it will have less polarization, or we can say less distortion. As it is having a less distortion, so it means there will be more stable negative ion. If more stable negative ion, you have to supply a lot of heat energy to break down this carbonate ion into oxygen and carbon dioxide. So as a result, it will form calcium oxide and carbon dioxide. But when we compare the temperature at which magnesium carbonate decompose with the temperature at which calcium carbonate decompose, so this will decompose at a high temperature and this will decompose at a low temperature. Is it clear? The trend in thermal decomposition, as we go down, it become more stable. So these periodic trends you have to learn. For the solubility of hydroxide, as we go down, the solubility of hydroxide increases, sulfate decreases, and thermal stability, as we go down, the thermal stability increases, like it become more stable down the group. So simple, a test tube experiment can also be done. So if we have like any carbonate is there, group 2 carbonate, we supply heat energy. So if you have magnesium carbonate in one experiment and another experiment you carry out with calcium carbonate, because magnesium carbonate can decompose first at low temperature, which release carbon dioxide, and as a result the carbon dioxide will turn this lime water milky. So in case of magnesium carbonate, the lime water will turn milky first. When we compare the thermal stability of group 1, the thermal stability of the group 1 element, like we have lithium is there, then sodium is there, then potassium is there. By mistake I said calcium. So lithium is there, +1, sodium +1, potassium +1. Example, lithium carbonate. Lithium is smaller in size compared to sodium, and sodium is smaller in size compared to potassium. When we check the carbonate ion will be same for lithium, the carbonate ion will be same for uh, sodium, and it will be same for potassium. But what happened, because lithium is smaller in size, so it causes more distortion to this carbonate ion as compared to sodium is, and they have a +1 charge, so they cannot cause too much distortion, because the distortion depends on the size of the positive ion, which should be small, and the charge of the positive ion should be greater. So there will be a distortion for this carbonate, but very small or no distortion. In case of lithium, yes, lithium is smaller in size, so it's cause a distortion. As a result, when we supply heat energy, lithium carbonate decomposes into lithium oxide plus carbon dioxide. But if you remember in O levels, IGCSE, we discussed when we supply heat energy to sodium carbonate and sodium hydroxide, they are stable to heat. So what is the reason why they were stable to heat? Like in that IGCSE, you just learned that they are stable to heat, but here is the reason for that, because these positive ions are larger in size and small charge on them, so they are not able to cause a distortion or polarization to the negative ion, and this negative ion will remain in, like as keep its shape, which will remain stable and does not decompose or break down into simpler one. So for group 1, only metal carbonate will decompose, that is lithium. Other rest does not decompose. Then thermal decomposition of a nitrate, as we go down the group, the thermal decomposition, like they become more stable. The same reason is there, because the magnesium is smaller in size, cause more distortion as compared to calcium. And group 1 nitrate do not decompose in the same way, except lithium nitrate is same, the other decompose to give nitrite plus oxygen. Whereas group 2 nitrate, when they decompose, it will give metal oxide plus nitrogen dioxide plus oxygen. And this nitrogen dioxide, it is brown in color. So when we decompose these carbonate, there is a brown gas evolved. So lithium carbonate or lithium nitrate decompose in the same manner as magnesium nitrate or group 2 nitrates. Whereas sodium, potassium, they decompose to form metal nitrite plus oxygen. And the reason is the same. Why the thermal stability increases? Because as we go down the group, the size is larger, so they don't cause too much distortion. Then carrying out a flame test, we should dip a nichrome wire in HCl and place on the hottest part of the flame, and we should be able to identify the substance on based on the flame color. Then the reason for flame color, less than a minute left, so I will share another link and continue this flame test.